For thousands of years, mankind has been greatly impressed by the majestic regularity of the stars moving in the skies. These sky watchers believed that all bodies of the firmament would find themselves in their original positions on the band of the zodiac at the end of a constant period. Little did they know that this time span had long existed and had been calculated by earlier civilizations. It was lost and forgotten as cataclysmic natural disasters and wars destroyed one civilization after another. Many tried in vain to find the great constant of the solar system and finally gave up. But this magic number finally appeared on an old clay tablet from Nineveh. Around the middle of the 19th century, the French consul, Paul-Émile Botta, observed that some of the mounds in Mosul, present-day Iraq, had perfectly rounded forms. He also noted the presence of pottery shards, indicating that these sites were ancient human habitations. Driven by curiosity, Botta dug one of these mounds in 1840. Besides the broken pottery, a considerable number of clay tablets were discovered. These tablets were covered with cuneiform characters. 2 years later, Botta met a young Englishman, Austin Henry Layard. Botta shared his excavation work with Layard, who quickly showed interest. In 1843, Botta received a small grant to dig up the Khorsabad hill. This is where the first Assyrian palace was ever discovered, and which belonged to King Sargon II. A large number of artifacts were unearthed, including bas-reliefs, statues of winged lions, and winged bulls. Later, Botta helped Layard to find Nineveh, the ancient capital of Assyria, and the palace of King Assurbanipal, with its tens of thousands of clay tablets, and the palace of Sennacherib. Layard's greatest discovery was the library of Assurbanipal, the Assyrian king, who had reigned from 669 to 626 BC. The library contained over 30,000 cuneiform clay tablets, and was a collection of all the science and history known at that time, assembled from previous civilizations. In Mosul, nobody could read the newly discovered clay tablets. They were shipped to the British Museum, where they rested for several years in the basement storage rooms. In 1872, the English Assyriologist, George Smith, began to translate the Kuyunjik tablets. These mention the Sumerian hero Gilgamesh, Enkidu, and Utnapishtim. Utnapishtim had warned about the coming deluge. So he built an ark to escape the flood, and eventually landed on the mountain, Nizir. What is intriguing is that the saga of Gilgamesh was older than Noah's account in the Bible. Smith also discovered that King Assurbanipal, known in history as one of the cruelest tyrants, recognized the importance of knowledge, as he learnt and assimilated all the known sciences of that period, mainly mathematics and astronomy. King Assurbanipal carefully preserved all materials at Nineveh, where the king's scribes translated and classified them in the library's repository. Among the tablets translated by Smith was a certain quantity that contained nothing but numbers, apparently derived from very complicated calculations. One of these numbers consisted of 15 digits. Researchers tried to find out what this number could have meant 3,000 years ago to the Assyrians, who were not known to be great mathematicians or astronomers. It seems that Assurbanipal must have found this number somewhere in Egypt, Chaldea, or Persia. A French communications scientist, Maurice Chatelain, who worked for the US government as an aeronautics engineer, and who had learned about the incredibly complex Mayan calendar, found himself wondering if there could have been any connection between the Assyrians of Nineveh and the Maya. He eventually realized that the Nineveh number was not as arbitrary as it looked. It was 70, multiplied by 60 to the power of 7. The Sumerians, who were the ancestors of the Babylonians, who in turn were invaded by the Assyrians, used calculations based on multiples of 60, more than 3,000 years ago. The Sumerians were great astronomers, who knew the revolution periods of all the planets of the solar system, including Uranus and Neptune. The Sumerians divided the day into 86,400 seconds, with 24 hours of 60 minutes of 60 seconds each. Could it be that the Nineveh Constant represents a very long time period, expressed in seconds? Could it be that this long period is the precession of the equinoxes, that is the turning of the terrestrial axis of rotation around the pole of the ecliptic? This movement has a cycle, approximately every 26,000 years. Chatelain subsequently wondered if the Nineveh number could express time in seconds. He calculated it to be 2,268 million days, just over 6 million years. Chatelain then recalled that the precession of the equinoxes takes just under 26,000 years to complete its cycle. This period is known as the Big Year. According to Colin Wilson, he then tried dividing this number into the Nineveh Constant, and found that it was an exact number of precession cycles. Exactly 240 big years. Thus, the Nineveh number represented 240 rotations of the seasons around the zodiac for the Sumerians. Time is expressed in seconds. Is the Nineveh number the great constant of the solar system? Chatelain investigated the Nineveh number, referred to as the great constant of the solar system, which would correlate to the revolution of all the cosmic concentrations of the solar system, including satellites. He then calculated the cycles of the planets in seconds, and found that each was an exact fraction of the Nineveh constant. Chatelain demonstrated that the Nineveh constant must have been computed around 64,800 years ago. Thus, the distant past of 27,000 years ago, when Cro-Magnon man painted the caves of Lascaux in France, or the temples of Tiwanaku built in Bolivia, indeed look like recent history. Even the oldest legends, telling us about the Egyptian chronology, dating back to 49,214 BC, or the Maya calendar starting 18,633 BC, or the Mahabharata Hindu calendar and 7,116 BC, now seem believable. But if people living on Earth 65,000 years ago were the primitive Stone Age humans, who could hardly fashion a flintstone, how could they possibly have calculated the Nineveh constant, based on the precession of equinoxes, a slow westward drift of 1 degree in 72 years, and the revolution periods of the planets, Uranus, Neptune, and the dwarf planet Pluto, which are invisible to the naked eye? Were our ancestors visited by ancient astronauts from another civilization, some 65,000 years ago? Who instigated the sudden evolution of man by improving his intelligence through the knowledge of astronomy, mathematics, metallurgy, and other secrets of civilization? In 2015, Gary Lachman put forward a very different perspective. Lachman states that the left side is the dominant part of the human brain. The right part of the brain is able to calculate such impossibly high numbers, not by systematic trial and error, but by intuiting the bigger picture. Lachman cites persons with the savant syndrome, who can take a number 16 digits long, and determine whether it is prime, or calculate the square root of that number, mentally. Lachman contends that the function of the brain's right side has been forgotten over the last millennia. Pluto's orbit inclines 17 degrees from the ecliptic, where the orbits of other planets are. It was discovered in January 1930 by the astronomer Clyde Tombaugh, only because it crossed the ecliptic at that time. This event will occur again in 2048, when this dwarf planet will return to the southern hemisphere. How could the ancients know of this dwarf planet, when Pluto is visible only with the most powerful telescopes, and its movements can only be detected by successive photographs? Without a doubt, our ancestors knew about the existence of Pluto, and used its sidereal year, together with the precession of the equinoxes, as the base of the great constant of the solar system, the constant of Nineveh. We have to wait till June of 2178, when Pluto will conclude its first revolution around the Sun, since this dwarf planet was discovered, to know the precise length of its sidereal year. Strangely enough, the number 90,720, which is a harmonic ideal, can be found on the second line of the fifth group of the Sumerian mathematical series of the constant. The current known length of Pluto's sidereal year is 0.009% from the Sumerian number. Our forefathers knew about the existence of Proserpine. This planet is much larger than Earth, and located at a distance of almost 10 billion kilometers from the Sun, with a revolution period of 512 terrestrial years. Our ancestors' astonishing knowledge of astronomy leaves many of us baffled. A good example is the planet Uranus, which is usually not visible with the naked eye. It sometimes shows up for a few weeks, with an apparent diameter larger than Mars, at its greatest distance from Earth. Uranus was well known, long before its official discovery by Sir William Herschel, in 1781, but it took some time to make sure that it was a planet, and not a star. The ancient sky watchers might have noticed the acceleration and deceleration of a known planet, when it passed another unknown planet. It was also established that the revolution periods of the rare comets fit perfectly into the cycle of the Nineveh Constant. Wiston's comet makes 10,800 revolutions around the Sun in 2,268 million days. Krig's comet makes 37,800 revolutions during the same time period. Halley's comet makes exactly 81,000 revolutions in 2,268 million days. We are still without an explanation of how our ancient ancestors knew about the existence of the Nineveh Constant. Upon studying the Dogon tribe, anthropologist Marcel Grell learned of their obsession with the Sirius star system. While Sirius A is visible to the naked eye, its companion white dwarf, Sirius B, was not discovered until the 1950s with an advanced telescope. However, the Dogon tribe were well aware of its presence, as well as its orbital period, describing its existence before it was confirmed years later. The Nineveh Constant is designed to fit the rotation of every planet into a certain round number of cycles, not in years as in the Mayan calendar, but in seconds. Chatelain was intrigued by two huge Mayan numbers that had been found on steles at Quirigua, in Guatemala. Translating these into years, he found that one number was just under 93 million years, while the other was 403 million years. He subsequently discovered that 93 million years is exactly 15 times larger than the Nineveh Constant, while 403 million years is 65 times larger than the Nineveh Constant. Indeed, Chatelain shows us that the Nineveh cycle existed on both sides of the Atlantic, as the Mayans had it as well, only in a different harmonic. The Nineveh Constant is also intricately connected to the Great Pyramid of Giza. This constant is obtained through the multiplication of the degrees of inclination and half of the Great Pyramid base in feet. To this day, one remains baffled about how the ancients acquired all this knowledge of astronomy. All of this suggests intelligent design with intelligent purpose. The more we assemble these pieces together, the more the entire function of the solar system, and possibly the entire cosmos, appears to be divine order. It seems there may be a law of nature which ensures that planets always form in certain orbits and always have certain sizes. This lends credence to the significance of a mathematical relationship that relates the orbits of the planets in our solar system. The cycle of Nineveh may actually be the shadows of the slow, continuous spiraling motions that we travel through as we change in position to the galaxy. Earth appears to have been consciously designed as a key planet for species evolution, as its system of years provide a similar anchor for the great solar system cycle.